about dependency confusion attack. If you go through these HackerOne reports, then you can see that multiple of these big organizations were vulnerable to this attack. You can read about them, just type this dork and you'll be able to get these reports. Now let's discuss what this dependency confusion attack is. In this report by HackerOne, they've told us about the dependency confusion attack, how it leads to supply chain attacks. Here you can see developers can import pre-written code into their projects, and thanks to open source repositories like npm for JavaScript and pypi for Python. So basically, as an attacker, you can create a code and put it onto a public repository from where the developers will then fetch your malicious code and use it into their code base, which will then further lead to code execution into the developer's PC or the server in which the application is running, which is basically much more critical than other scenarios. So that's why this vulnerability is much important to discuss about, and should also look out for such kind of misconfigurations during your pen test or bug bounties. If you scroll down, you can read more about this attack here. It basically tells how the collision between private and public registries leads to this kind of attacks. Here you can see if a package exists in both the repositories, then the package with a higher version number will take precedence. So in this video, I'll show you by creating a demo web application where I'll show you how the developers introduced this vulnerability unintentionally in the first place, and how you as an attacker can look for this vulnerability, or basically what to look for in the application while testing for this vulnerability. So let's dive in then. So you can see there are multiple languages in which you can identify this vulnerability, like Python, Node, Ruby, PHP, but it is mainly found in NPM, that is Node, as most of the web applications are developed in Node. I've created this chart to explain you the flow of the attack. So in the first step, here you can see that the developer or the CI/CD pipeline executes this command npm install package name. Then npm looks for this package or dependency in registries. So registries are like libraries where all the packages and dependencies are stored. Now, whenever a developer needs these packages, they basically fetches it from the registries by using the command npm install package name and downloads the dependency from the particular registry. Now, these are the type of registries that are available: public registry, private registry, and then the other type is where the developer stores the package locally into their system. In public registry, we store all the packages which are open sourced and could be used by anyone. I'll show you. So this is the website where you can search for the public registries. If I type here Express, which is a very well-known package, you can see it shows me all the packages with the name Express. And these are all the public packages. Then comes private registry. Now, private registries are used by companies or organizations to store sensitive internal packages. Now, let's say a company has an authentication module which they uses into their code. Now, they can't really make it public and let everyone see that. Then hackers could easily reverse engineer it, then exploit them, and could lead to account compromises or sensitive information leakage. So that's why they uses this private registry to store their packages, which are only accessible to the company itself. They can host this particular registry into their internal network and then further use it. Then comes the third case, where the developers store the packages locally, and this is where things get exciting. Attackers look for dependencies in publicly available JS files, package.json, or other relative files. Package.json files are basically the files which stores the information of the packages or dependencies that are used by the application. I'll show this to you during our practical demo. Meanwhile, let's just understand the flow first. Once we identify the package names, from the package.json or any other available JS files, then we'll look for the dependencies. This won't be private, this will be just dependencies. So after we fetch all the dependencies from the publicly available JS files or package.json, then we will check those dependencies are available on the public registry or not. Now, if they are available into the public registry, then we cannot exploit further. But if they are not available onto the public registry, then what we can do is, as an attacker, we can create a malicious dependency with the same name as the private dependency and then publish it in public registry with a higher version. So this is the feature of npm that we'll be exploiting here. So now let's look at what this command does. That is, did the developer mention if the package is an internal package or not? The developer can mention within the package.json file itself. This tells npm that it is an internal package and it should only be installed from an internal registry. So again, if the answer is yes, then we cannot exploit further. But if the answer is no, then it asks that if this package is stored locally. If the answer is no, then it means that the package could be installed from the public repository. And if yes, then npm will compare the versions. And if yes, then also npm will check the public repository if the package is available. And if it is also available in the public repository, then it will compare the version of these two packages, the ones that is stored locally and the ones that is available in the public registry. Then compare the versions of the packages, the one that is stored locally and the one that is available in the public registry. Let's say the public registry has a version of 2.0.0 and the private registry has a version of 1.0.0. Then by default, npm will choose the higher version, that is 2.0.0, that is available in the public registry and has been uploaded maliciously by the attacker. npm will then download it from the public registry and the attack will then be successful. So this is the entire attack flow that we'll be now demonstrating practically. So now here I'll create two directories. I'll open my VS Code here. So the goal is here in this app directory, I'll create the application and then in the attacker package, I'll create the malicious package that the attacker will use to exploit the application. So let's get into this app directory now and type npm init-y. So now it have created a package.json file in the app directory. So this is the package.json file. Here you can see in the main we have an index.js file. So let's create this file now. So first of all, we'll import the express library here. Then app is equals to express. After this, I'll just introduce the base directory here. I'll just type hello world. So basically this is the base directory when I'll start the node server. So in the base directory, I'll receive a message of hello world. After this, now I'll create a path to view the package.json file. Now I'll create a listener on port 3000 so that we can access the application at that port. Now I'll just save the file and open the terminal here and I'll just type node index.js to run the application. Okay, here it says module not found and express. Okay, so here we've imported this express library, so we'll just have to install it before proceeding. So for this, I can just type npm install express. So the installation is done now. Here you can see we have some new folders and files. First is node modules. This folder contains all these packages. Here you can see we also have Express here. If you go to this index.js library, then we can also see the code from where it exports this path. We go inside lib, we can see express.js, and this is the code it's using. Inside the package.json, here you can see in the dependencies we have now express and its version mentioned. Similarly, in the package log.json file also, we have information about the modules that we will be using. Now, let's create an internal module which will be importing into this application. For this, I'll create another directory. I'll call it .NET dispatches internal. I'll go inside this directory. Then again, npm init-y. Here we have the package.json file. Now again, I'll create this index.js file. So here I'll just type a simple message so that we can understand that this module is being used now. Let's save the file. Package.json will also save the file here. Here inside this index.js, we'll have to import our package. Save the file. We're getting some error here. Let's check it. We can ignore it. Now, let's again execute the application. We'll have to go to the app directory again. In the app directory, I'll just clear the screen now. Let's execute node index.js. Now again, here you can see we're getting this error can't find module .NET dispatches internal, because here in the node module section, you can see that we don't have any module here called .NET dispatches from where npm will basically fetch the package and then use it within the code base. For this purpose, we'll first have to link this package. So let's do it. For this, we'll have to go to the .NET dispatches folder again. Here, type npm link, another error. It says permission denied. So let's just use sudo here. You can see now the package is linked. Now we'll have to go to the app directory again, and we'll also have to link it here. Now we'll have to type npm link and then the package name so that this app directory knows what package we're talking about. Here you can see now the package is also linked here. Now if we go to the node modules directory, here you can see the .NET dispatches internal module is now available here also. I'll just clear the screen again. Now let's execute the application. And here you can see our application is running, and also the internal module that we've created is now being used. Let's browse the application now. Go to the browser, type localhost 3000, and here you can see hello world. If I visit package.json, then here you can see our package.json file. So this was your developer's POF. Now let's look into how attacker creates a package and publishes it, and then developer installs it and then further uses it into their application, due to which they gets compromised later. For this, I'll go into attacker package directory now, and I'll create the package there. Here also I'll type npm init-y. There you can see. Okay, here inside this folder, I'll have to create a folder called .NET dispatches internal, and then I'll have to create this package.json file. So let's delete it. Now, here you can see we have the correct package.json with the proper name and version. We'll have to increase it, as the legit internal package also has version 1.0.0, so we'll have to create the malicious package with a version higher than the legit one. So I'll just make it 2, save it, create an index.js file here. So here I'll write some code that will tell me now it's the malicious package running, not the legit one. save this file. Now we'll have to publish this package onto npm. So for this, first you will have to visit the npm website, create an account if you don't have one, and enable the two-factor authentication, because this will be required for uploading the package to the npm.js library. If you don't have it enabled, you will be getting some errors, so please make sure to enable it. Now let's go back to the terminal again. I'll type npm login first, click onto this URL, and I'll just fill it. Due to some reason, I'm not really getting the OTP onto my mailbox, so I've just used my mobile device. I've just used my security key to log in into this. Uh, Due to some reason, I'm not receiving OTP onto my mailbox, so for that purpose, I've used my security key to log in into this. So now, here you can see I've successfully logged in. And if I now type npm who am I, will give me the name of the username of the account. So now make sure you're into the directory where you have created the malicious package, and being there, you need to use the command npm publish to publish the package. So now here it will again ask you for the authentication of your account, and for this purpose you will now also again have to use the security key. I've did the setup into my mobile device, so I'll be using that. So here you can see now the package is successfully uploaded into the npm public registry. Name of the package is darknet dispatches internal and the version is 2.0.0. Here you can see darknet dispatches internal in the code. Okay, seems like index.js file is not uploaded here. Let me check the directory once again. Oh, it's a silly mistake here. You can see I've created this index.js file outside the darknet dispatches internal directory. So that's why it was not tracked. Now I'll have to publish this again. So let's fix it. Just drag this directory into darknet dispatches, and yep, now it should work. Control S, go to the terminal again and just rerun the command npm publish. Okay, here you can see 403 forbidden error I'm getting now because I've already published the version 2.0.0. So now I'll again have to update the version number of this package to publish the package again. So let's change the package.json file also. And here I'll type 2.1.0, save it, and publish it again. Here you can see now darknet dispatches internal 2.1.0 is now published. If I go there and refresh the page, here you can see now index.js and package.json. If you want to check the versions, here you can also see the versions. So now let's install this malicious package onto our application. For this, I'll again have to cd into the app directory, npm install darknet dispatches internal. Now here you can see we have installed the malicious package. If I go to the package.json, darknet dispatches internal, and it's the version 2.1.0. So let's verify it if the code inside the index.js file gets executed or not. For this, I'll again have to execute index.js file. And here you can see our malicious package is now successfully running. In the next step, we can try to exfiltrate data from the developer's machine, which is basically the main motive of the attackers. So let's see how we can do that. So first, let's see how we can modify the index.js file to do it. So here, my main goal is to import the HTTP library, and then I'll use it to call my server, which I'll host using Python, and then exfiltrate the data using HTTP requests. So let's see how we can implement it. First, I'll import the library. So here, I'll just fetch the username and the time. If I cannot fetch the username, then I'll just print unknown. This is a JSON data. Now, if I want to exfiltrate this data through HTTP requests, then I'll have to convert it into base64 so that it doesn't get detected and it's a valid format to be sent via URLs. I'll convert it into base64. Now I'll structure the request. It will be a GET request, and we can use this format here. Just instead of attacker server, I'll use localhost and port will be 8081. And instead of this, I'll just use a dollar and encoded. And here, instead of inverted commas, I'll use tilde. Remove the plus sign here. Yep, this is the format. After this, now here, let's just handle the error. And yeah, we can use it. Let's test it now, save it. And inside the package.json, we'll have to again increase the version. Here, let's make it 2.2.0. Let's now publish it again. Close it. npm publish. Need to authenticate. Okay, here I'm getting an error. Okay, I've actually published it in the app directory, which I shouldn't have done. I'll have to go into the attackers directory, so that's why I'm getting this error. Let's go to attacker, sorry, cd. Need to come back, attacker package inside darknet dispatches. Again, npm publish here. Here you can see now it's published 2.2.0. If I go into the browser, oops, no need of that. Here, refresh it. You can see 2.2.0 is uploaded. Now let's go back here and in a separate terminal, I'll first have to boot up my Python server. So I'll just put it up here, python -m http server 8081, because this was the port I've mentioned here. You can see 8081. So enter, and now let's check if our exploit works. I'll again have to go to the previous directory, I mean in the app directory. Now here, if I again install the darknet dispatches library, then I guess I should have got a callback. Okay, I didn't receive any callback here now. Let's check it manually once if it works. Here, yeah, it does work here. I think I should just check the version here. Okay, here you can see I've made an error here. It's a typo I did. Okay, let's fix it again. Save it. Change the version number 2.3.0. Save it. Now go back. Publish it again. Not here. I'll again have to go to the previous directory and do npm publish. Okay, authenticate. Now the package is now successfully uploaded. Let's go back here. Require and all good, I guess now. Go back to the terminal. Here, let's clear it and start a fresh one. Back. Need to go back into the previous directory in the app directory and npm install darknet. I'll just execute the application now. Here we're getting connection refused error. So let's just check. Okay, our server is down. So let's boot it up again. And now if I do node index.js again, I've now got the data. So here, if I just extract it, close the server, then echo and base 64-d. Okay, it's invalid input because I didn't copy the full data. Let's do it again. Base 64-d. So here you can see now we have exfiltrated the data. So similarly, we can use something called pre-installed scripts in the package.json file, which will basically execute the code before installing the module itself, and we can then use it to extract data again. So now, instead of using my local server, I'll be using request bin. So for that, let's go to request bin now. You can sign in here using your email address, or you can also continue as a guest. Now you can use this one. Just click on it, and this will be your address. Now let's just create the payload. Pre-install, and here I'll type curl -s http and then slash. You can do something like collect question mark data is equals to dollar, then you'll say who am I, and then at the rate dollar host name. Now change the version, make it 2.4.0. Control S. Here would be npm publish. Let's go back to the app directory. Again, npm install darknet dispatches internal. Now let's check the package.json. You can see 2.4.0. Let's go back to the terminal now, and let's wait and see if we get a callback here. And here you can see we're getting multiple HTTP and DNS requests, but the commands here didn't execute it. So I'll just have to fix it again. Here, instead of this, just add backticks here. Oops, not this way. Yep. Because these commands were basically getting treated as text since I have included them inside double quotes. So now with backticks, let's check if it gets interpreted as a command. Change the version again, 5, and go back to the terminal. Here, again publish it. Okay, I'm getting an error 2.4.0. I guess I didn't saved the file. Save it and again publish. Okay, it got published. Now again install the module. Let's just clear this. Okay, so here you can see now I'm getting the data. I guess previously it was due to some cache or something. This is the user. I'll be closing the instance now and I'll be deleting it. So these are some of the ways using which you can exploit this dependency confusion vulnerability. You can see that it is not much tough, but yes, if you do proper recon and you are able to get those private packages which are not configured properly, then you can definitely exploit it and you can report it to the owner. Now, in order to fix it, the developers need to make sure that they segregate the public packages and the private packages differently, and if they do store it locally, then they should mention the path of the dependency from where it should be installed. And it's really easy to configure it properly. Just instead of this, you need to type file and the path of the package, which in our case is this. So that's it for this video, guys. Please let me know if you like it, or if you have any doubts, then definitely comment. I'll also be writing a blog on Medium, so all the required documents and everything you can find it there. And please do like this video and share it, and subscribe to my channel if you want to see more such contents, as now I'll be releasing more contents regularly. So let me know which topic you want to see next, then I'll definitely create a video on it. Thank you.